In 1995, one of the most powerful scientific instruments ever built was pointed at a place that barely seemed worth looking at. The target was not a bright object. It was not a famous destination. On photographs of the sky, it appeared almost empty. Then came the decision. The Hubble Space Telescope would spend days staring at that tiny patch anyway. That choice carried a cost. Every hour spent looking there was an hour that could not be spent somewhere else. Time on Hubble was limited, valuable, and impossible to casually replace. If the patch really contained nothing important, the telescope would be doing little more than watching darkness. From a distance, the gamble seemed difficult to justify. The region looked quiet. It looked ordinary. It looked exactly like the kind of place astronomers could safely ignore. But once a machine this valuable commits itself to a target, the consequences become real. Resources are consumed. Opportunities disappear. The decision cannot simply be taken back. Now the assumption itself was under pressure. If empty-looking space can be trusted, this was a mistake. If it cannot, then something about the sky is already being misunderstood. And that raises an uncomfortable question. Why spend days looking at a place that appears to contain almost nothing? The image did not change all at once. At first, the field still looked mostly empty. The decision to keep watching seemed increasingly difficult to justify. Then, a faint point appeared. Not a dramatic burst, not an obvious discovery, just a tiny mark where nothing had been visible before. The observation continued. Another point emerged, then another. As more exposure accumulated, the dark background slowly began losing its certainty. Small features started appearing across the image, scattered through a region that had seemed almost blank when the process began. That created an uncomfortable problem. The original interpretation had been simple. If almost nothing could be seen, then almost nothing was there. Now, that explanation was becoming harder to defend. The field itself had not changed. Hubble had not moved to a different target. The only thing changing was how much information had been collected, and each additional period of observation seemed to reveal something that had been hidden before. The consequence reached beyond this single image. If a place can appear empty while containing objects that remain invisible at first, then seeing nothing is no longer reliable evidence of absence. The limitation may not belong to the sky at all. It may belong to the act of looking. And if deeper observation keeps uncovering more structure, there is no obvious way to know how much still remains beyond current visibility. The final image arrives, and the uncertainty seems to disappear. What began as a nearly blank patch of sky is now crowded with visible structure. Across an area no larger than a grain of sand held at arm's length, thousands of galaxies fill the frame. The transformation feels decisive. Nothing new was placed there. Nothing suddenly appeared in the sky. The objects were already present. Hubble simply remained focused long enough to reveal them. That makes the result seem straightforward. The field looked empty because previous observations could not see deeply enough. Better instruments collected more information. Hidden objects became visible, and the problem was solved. In that version of events, the lesson is comforting. Nothing fundamental had changed. The universe was exactly what astronomers thought it was. The only thing missing had been the ability to see it. The gamble worked. The image appeared to prove that better observation was the entire answer, and for a moment, that explanation feels complete. The sky was never empty. The telescope finally became powerful enough to show what had been there all along. But if this is only a story about seeing farther and seeing better, one question remains. Why did this observation become so important in the first place? The image now looks solved. Thousands of galaxies fill the frame. The empty patch is gone. The hidden structures have been exposed. It is easy to believe the mystery ended the moment Hubble became powerful enough to see them. But then, a different detail begins to matter. Not where these galaxies are, when they are. Some of the galaxies inside the Hubble Deep Field are so distant that their light began traveling toward Earth long before human civilization existed. Some were already sending that light across space before familiar continents looked the way they do today. That changes what is actually visible in the image. Two galaxies sitting next to each other in the image may not belong to the same chapter of cosmic history at all. The frame is not showing a collection of objects from a single moment. Different galaxies are arriving from vastly different periods. The farther away some of them are, the farther back their visible evidence began its journey. Suddenly, the earlier explanation starts to fail. Better optics alone cannot explain what is happening. A stronger telescope can reveal fainter objects, but it cannot turn a simple map into something else entirely. The deeper astronomers look into this field, the less it behaves like a snapshot. Distance is no longer just distance. Every increase in distance also becomes an increase in age. What first looked like a crowded patch of sky begins behaving like a stack of different eras compressed into a single image. The number of galaxies is no longer the most important thing in the image. The field is no longer functioning like a map. It is beginning to function like a timeline. And that creates a new problem. If evidence can survive across billions of years and still remain visible today, why has that evidence not disappeared? Light is still arriving. That is the detail that changes everything. The galaxies inside the Hubble Deep Field remain visible because the information they released did not vanish. It kept traveling. Across enormous distances, that evidence continued moving until it finally reached Earth. The image captures that arrival. Each point of light carries a record from an earlier era. The deeper observation reaches, the older the arriving evidence becomes. That transforms the meaning of the field. The galaxies were never remarkable simply because they existed. What made them extraordinary was that their evidence survived the journey. The image was not showing what is out there. It was showing what managed to reach us. What appears on the screen is not just a collection of distant objects. It is a collection of preserved records. The original blank patch of sky now looks completely different. A region once dismissed as empty revealed hidden structure. Then that structure revealed age, and that age revealed something larger. The night sky is not merely a backdrop filled with distant lights. It is a record that keeps delivering pieces of the past into the present. Every successful observation captures information that has survived a journey long enough for the original reality to change before the evidence arrives. That is why the Hubble Deep Field mattered. The telescope was not simply looking across space. It was collecting evidence from realities that no longer existed in the form being observed. What appeared to be a tiny patch of empty sky turned out to be a place where the universe had been storing evidence the entire time.